Okay, so I had explained the definition of collinear points. We'll revise what is collinear points, and then we'll do one sum based on collinear points. So it is said if the points lie on the same line, then the points are said to be collinear. Okay? If the points lie on the same line, then they are said to be collinear. So this is an example I gave. A and B are collinear, so they lie on the same line. Similarly, A, B, C are collinear, but in this case, PQR was not collinear because PQ and R do not lie on the same line. Okay, so points lying on the same line are collinear. So we'll do one example of checking whether the points are collinear or not. So in this sum, this is an example sum in the textbook. It's already solved. I'll explain this and then we will move on to the exercise. So it says, show that the point A with coordinates -3, 2, B with coordinates 1, -2, and C with coordinate 9, -10. These are these three coordinates given to us, or 3 points given to us, and we have to show or we have to check whether these 3 points are collinear or not. Now, we know the definition of collinearity. Collinear means points lying on the same line. But when we have to prove it, what do we do? Okay, so these 3 points are given. Point A with coordinates -3, 2, point P with coordinates 1, -2, and point C with coordinates 9, -10. Okay, so first what you do is you find distance AB. Using distance formula, find distance AB. Then, once you find out distance AB, next you go to find out distance BC. Using distance formula, that is distance between point P and C. And last, once you find BC, last you find distance AC. That is these two. Distance AC. Okay. You find out. So the general idea, initial step clear, what has to be done. So in the initial step, find distance AB, distance BC, and distance AC using distance formula. Okay, so let's find out one by one what are the distance. I'll start with distance AB. Okay, so when I'm finding distance AB, this will be x1, y1, and I'll consider this to be x2, y2. So I'll write here by distance formula. So as I said, whenever you're using a distance formula, make sure you write the formula first. So x2 minus x1 the whole square plus y2 minus y1 the whole square. So now, can you tell me what will be x2, x1, y2, y1?
X2 is 1, x1 is -3,
the whole square.
y2 is -2, and y1 is 2.
Okay. So now this will become 1, minus into minus will become plus.
Plus
1 plus 3 the whole square plus -2 will become minus.
Minus, but we'll do addition, so -4.
Correct. So it becomes -4 the whole square. This becomes 1 plus 3, that is 4 square plus -4 square. What's the square of 4?
16.
16. And square of -4?
16.
16. And 16 plus 16 will give you?
32.
32. And one thing if you know, we can reduce this. So how will you do? Write 32 as
16 into 16 and 2.
2, correct. And then we'll distribute the square root. So root of 16, root of 2. So we know square root 16 is 4.
4.
So this becomes 4 root 2. The distance AB is 4 root 2. So I'll just name this as 1. So first, I found out distance AB. Next, we'll find out distance BC. Distance BC. Now in BC, now when you're using BC, what will be x1, y1 and what will be x2, y2?
X1 will be 1.
Correct.
And y1 will be 9.
So this will be x1, y1 and this will be x2, y2. So again, by distance formula. So I'll write a formula first. It becomes x2 minus x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we'll just substitute the values. X2 is, can you see and tell me what will be x2, x1?
X2 will be 9. X1 will be 1. Y2 will be minus 10. And Y1 will be minus 2.
Minus of minus 2 the whole square. Okay. So we'll simplify it. So this is first I'll write this as it is.
Oh, okay.
Here, minus into minus, it will change to minus 10 plus 2. The whole square. Okay, now we'll solve it. So 9 minus 1 will be
8.
8 square plus. What about this? Minus 10 plus 2?
Minus 8.
That minus 8. So it becomes minus 8 the whole square. Okay. What is the square of 8?
64.
64. And minus 8 will be?
64.
64. What is 64 plus 64?
128.
That's 120. Now we need to reduce this. See, we need to reduce this. 128 is it. So what we'll do to reduce this, we'll use the prime factor method. You remember 128. This is divisible by 2, so you keep dividing it by 2. So 2, 6 are 12, 2, 4 are 8. Again, it is divisible by 2, so 2, 3 are 6, 2, 2 are 4. Okay, now again we can do it. So 2, 1s are 2, and 2, 6 are 12. Next 2,
8.
8 is 16. Next 2 and 4. Then 2, 2, and then last 2, 1.
1.
So when we get 1 here, we stop. Now what you do is you make pairs. So this is 1 pair, 1 pair, 1 pair, and then we have a single 2. Correct? So
yes,
how much ever pairs are there, that you have to multiply. So from here, 2 into 2 into 2, that will be
8.
No, you see the pairs. See the pairs. How many pairs are there? 3 pairs are there.
4. Oh.
Yeah, 4. Correct.
3,
4.
3, 6.
No. We have to multiply. We have to multiply. Are you confused here?
Yeah.
if you see, there are 3 pairs. So from the first pair, you write the 2. From the second pair, a 2. And from the third pair, the 2. And you see the single is 2.
Yes.
That you write in the root. Okay, whatever is single, that will be written inside the root. Is this clear?
Yes.
Now 2 into 2 is 4. 4 into 2 is 8.
8.
So this becomes 8 root 2.
Yes.
Is this method clear? Reducing?
Yeah.
If you have not understood any difficulties, you ask me again, okay?
What if there is no single 2 remaining at the last?
Then you don't put it inside the root. You just directly multiply. So suppose, for example, there would be one more 2 here. Okay?
Yes.
Then you will have one pair here.
Yeah.
Then you will multiply. Here you will, instead of this root, you would have just multiplied, directly multiply. No root sign.
Okay, okay.
Okay? But here, since there was just 1, 2, which was not forming a pair, that you put inside the root because we are finding out square root.
Okay.
Okay, so I'll put this here. So our final answer, distance BC, is 8 root 2. So this I will number this as 2. So we have found out 2, distance AB and distance BC. Next, we will find out distance. Which one is remaining now?
AC.
AC, correct. So when you're finding out distance AC, I'll do it here. Distance AC. So I'll write a formula first. X2 minus X1 the whole square plus Y2 minus Y1 the whole square. So A has coordinates minus 3, 2.
Minus 3 and 2.
C had coordinates 9, 10.
9, minus 10.
9, minus 10. So this becomes X1, Y1. This becomes X2, Y2. So now we substitute the values.
Yes.
Can you tell me?
9 and minus 3.
9 minus of minus 3, the whole square. Plus Y2.
Minus 10 minus 2, the whole square.
The whole square. Okay, I will simplify. So 9 minus of minus 3 will become plus. So 9 plus 3, the whole square, plus. Minus 10 minus 2 will be?
12, minus 12.
Minus 12, correct, the whole square. Okay, and 9 plus 3 is also?
12.
So 12 square plus minus of 12, the whole square. So yes. What is the square of 12?
144.
144. And square of minus 12?
144.
What is 144 plus 144?
288.
Correct, 288. Now we need to reduce this. Okay, so we'll use the same method that we used in our previous sum to reduce it. So I'll write here 288. And as you see, 288 is divisible by 2. So we'll keep dividing it by 2.
144.
So 2,
okay.
144. And again, 2.
7, 2.
Again, we can do
3 and 6.
Then,
and then 1 and 8.
18. Then 2, 9.
9.
Okay,
and
now
then 3.
3, correct. 3, and last
3,
again
1.
1. Now we'll do the pairing. So this became one pair. So I'll make pair and I'll immediately write here. So it will be easy for us. So 2. Then this is the next pair. So I'll write again 2. Then this is one pair of 3 that is happening. So 3.
What about the 2?
And this 2, so it is single. So what we'll do when it is single, you put it. Where do you put?
Put it in the root.
Correct. So that was single. So I'll put it in the root. Now do the multiplication. So 2 into 2 is 4. 4 into 3 is
12.
12. So this becomes 12 root
2.
Is this clear?
Yes.
Okay. So this was last distance AC. That was 12 root 2. And this I'll number it as 3. Okay, is this clear up to here? We found out distance AB, distance BC, and distance AC. Okay, so I want you to write up to here. We have not yet finished with the sum, okay? Write up to here, and then I'll continue with the next step. Can you see? Is it visible? Okay.
Yes, it is visible.
So, do you want me to zoom in?
No, I have zoomed.
Okay, okay. So the last, this thing when you want to see, then just let me know, I'll shift it.
Yeah.
Okay, so we'll move on to the exercise sum. So in the exercise, 5.1. The first part we have finished, so now we'll start with the second part. Second part says, determine whether the points are collinear or not. That means the same thing. We have to check whether they lie on the straight line or not.
Yes.
So we will start with the first sum. Exact same technique we will be using. So here if you see, determine whether these points are collinear or not. A has coordinates 1, minus 3.
I have to do that?
Yes. B has coordinates 2, minus 5, and C minus 4, 3. So first find out distance AB and tell me what it is.
Yes.
Make sure you write a formula first.
Root 5 and 5 root 5.
Correct. That is AB and AC. These are the two smaller distances. So you add them. So distance AB plus distance AC. So that is root of 5 plus 5 root 5. How much will this be? 5 plus 5 root 5?
6 root 5.
How 6?
I don't know. 6, right? Because before the root 5, there is 1.
Yeah, correct. Correct. Be really confident. You're correct. So here, there is no number, means it is 1. So 1 plus 5, that means is 6. 1 plus 5 is 6. And then that root 5 as it is. So we have 6 root 5, which is same as your distance BC. So it is satisfying this property. So distance AB plus distance AC is equal to the third distance BC. Okay, so from here you say that points A, B, and C are collinear. Is this clear? This sum?
Yes.
Okay. Write this last part. Okay, can you do the second one as well? L, M, and N.
Yes. Three root 5?
Correct. 3 to 5. Next, go for distance DMN. Distance MN.
I'm getting it at root 65, but when I go to the thing like this, it's still not.
Yeah, correct. You're getting root 65, right?
Yeah.
Yeah, it's
But
correct.
5 and 13?
No, 65 is a prime number, so you cannot reduce it. It is not
It
possible
will
to
remain
reduce.
65.
Yeah, you leave it as it is.
Okay.
So this you leave it as it is, root 65. Okay, the reason If you want to write it, 65 is a prime number. So it's not possible to reduce. Now go for finding distance ln. Okay, one mistake. See, it is 4 minus 3. How much is 4 minus 3?
Okay. So again, I'm getting 5. I mean, I'm getting root 50. So after doing that, I get 5, 5, and 2.
So 5 root 2.
Yeah.
Correct? Oh, now we have to check whether they are collinear or not. Okay. Now, one thing, if you notice in this, inside the root, in all the 3 cases, there are different numbers inside the root. Now, whenever inside the root, there are different numbers, you can say that they will not be collinear. Okay? So, or else if you add the 2 smaller sides, which are the 2 smaller sides in this, or 2 smaller distances?
3 root 5 and 5 root 2.
Correct. These are the 2 smaller ones. So if you add them, distance Lm plus distance Ln. So that you will get 3 root 5 plus 5 root 2.
Root 2.
Okay, but now we cannot add this. 3 and 5 we cannot add. The reason being the roots are different. Okay, the roots are different. So you cannot add, you leave it as it is. And this you write is not equal to distance of M. Is this clear?
Yes.
So from here we can say that points
L and N are not collinear.
Correct. L, M, N are not collinear. Okay, you can write this.